All right, this is section 7.3 called the ambiguous case. So just to refresh, I put the chart here again that we had from the first section, 7.1, that just kind of outlines which cases you're able to use which laws. And so remember in 7.1, we dealt with cases in which you had two angles and a side. Didn't matter if the side was between the two angles or not. If you have two angles of a triangle in one side, then you can always use law of sines. In 7.2, we dealt with special cases where you knew either two sides and the angle between those two sides, in which case law of cosines would have to be used. Or if you knew all three sides and you were trying to find the angles, then you would have to use law of cosines. So we've dealt with law of sines and law of cosines under those conditions. Angle, 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 there is no, that is unable to be solved by either law of sines or cosines because there's many different size triangles that can have three angles given. I mean, it just doesn't tell you that anything about the lengths of the sides. So now we go to 7.3 where we are dealing with the side angle case. So this is the ambiguous case. Now it's called the ambiguous case because there can be, give me two sides and an angle. If it's not the angle between the two sides, it's potentially possible for there to be two triangles that have the same size, same length of sides and angle. So you can have two different triangles that have two sides and an angle the same. In other words, if I know the two sides at an angle and it's not the angle between the two sides, there can be two totally different triangles that have those parts. Now, there won't always be, but there can be, and that's why it's called the ambiguous case. So let's jump in here and look at some different cases that can arise from the side angle situation. All right, so let me call this triangle A, B, C. Label it as it's given. So angle A is 35 degrees. Side A is 4. And side B is 12. All right, and I'm asked to find angle B. So I don't have to solve the whole triangle, I just have to find angle B. So this one is a case, there's the side, and the angle. So it's two sides and an angle. It's not the angle between the two sides. So this is the side angle case. So this is the ambiguous case. So I'm going to try to solve these using law of sines. You can also do them using law of cosines. We'll actually come back after we do 3 examples by law of sines. We'll come back and show that you can also do those by law of cosines. All right, so I'm going to set up, I've got side A, I've got angle A, I've got side B, and I'm looking for angle B. So this is A divided by the sine of angle A equals side B divided by the sine of angle B. All right, and I will fill in A is 4. Angle A is 35 degrees. Side B is 12, and sine of angle B is what I'm trying to find. All right, so a proportion. So we solve a proportion by cross multiplying. So 4 times the sine of angle B is equal to 12 times the sine of 35 degrees. Divide by 4.0. All right, and so I have sine of angle B is equal to, so let me pull up my Desmos calculator on here, and we'll type that in. Okay, it was 12 sine of 35 over 4. 12 sine of 35 over 4. And I want to always make sure I'm in the right mode. I'm in degree mode, so everything's good. So go back a second. Yeah, okay. So 1.721, we'll say. So sine of angle B is 1.721. All right. Now I can stop right there because if you remember, the sine of an angle can't equal 1.721. It can be bigger than 1. So remember, sine can't go above 1 or negative 1. It is that means that the opposite to the adjacent would be bigger than 1. That means the opposite side has to be bigger than the hypotenuse. That can't be. So basically, if you put it in a calculator, you inverse sine of 1.721, you're going to get error. So the answer is there is no answer. There is no triangle possible. You could not make a triangle with an angle 35 degrees and this side 12 and this side 4. Not possible. All right, so that can happen. So you can have no triangle possible. So I'm going to say no possible triangle with those parts. So good enough. All right, let's go to another case. Whoops, okay, I've already written that one out. All right, in this triangle, let me draw it. I'll draw it over here in the space that I have so I can save my room. All right, so angle A, that's given. Call this angle B. Angle C, side A, 52 centimeters. And side B, 64 centimeters. All right, this time we have to solve solve for all the missing parts. So we have to find angle B and C and side C. Okay, so I know side A, I know angle A. So let me start out A over the sine of angle A equals B. No, I'm trying to find side C. So, well, I have to do that because I can't do C yet. Okay, so I know B. Since I know side B, I'm going to have to do B over the sine of angle B. So I know everything except angle B. So I can fill in side A is 52 centimeters. Angle A is 42 degrees. Side B is 64 centimeters, and angle B is what I'm trying to find. All right, so I cross multiply 52 times the sine of angle B equals 64 times the sine of 42 degrees. And then we divide both sides by 52. And we get the sine of angle B equals, and then I just need to put that in my calculator, 64 sine of 42 over 52. Those angles backwards. 64 sine of 42 over 52. Sine of 42 over 52. All right, and so 0.8235. 0.8235. And angle B then is going to be the inverse sine of 0.8235. Okay, so the inverse sine of 0.8235, I'll go back to my calculator and inverse sine, let me just do this. Okay, so, and I'm in degrees, so in 55, do I want to, let me see where I'm going to round. All right, angles are two significant digits, so I'm going to keep it at 55. So 55. All right, so angle B is 55 degrees. Okay, now remember, the sine of 0.82, the sine of 55 degrees is 0.825, but so 55 degrees is one solution. But remember, the sine of an angle in quadrant 2 will also have there's an angle in quadrant 2 that will also have a sine of 0.8235 positive. And so that would be the same angle, same reference angle over here, which means it would be 180 minus 55, which would be 125. So there's two angles. So B could be 55, but it could also be 125. So let's go back to our triangle here. So B could be 55. And so 42, I can find angle C just using the 180 degree rule. So if B is 55, 55 plus 42 is 97. 97 from 180 is 83. So this angle must be 83 degrees. So what if angle B, instead of being 55, what if it was 125? Well, 125 and 42 is 167, which would make this angle 13. So there's two possible triangles that can happen here. Let me draw the other one just so we can kind of see it. So what the other one would look like would be, so this would still be 64. And this would actually end up being, so it's kind of like if I could swing this side through, I could just take this side and swing it through and it comes in and it would make this kind of, let me draw it a little bigger here. All right, so let's say I swing this side through and it would come over. So here's C. So it was out here and then I'm going to swing it through and now it's going to be here. So there's my B now. This was the old B. And then this is A. And there we go. So this is still the same length, 64, 64. This is still the same length, 52. It's just I've swung it through, so 52. And this is still 42 degrees. And B, though, now is 125. So I'm going to put 125. So it's the other angle. I just made a separate triangle instead of trying to label them both on the same one. And the other angle up here then, 42 and 125 was 167. 167 from 180 makes this little angle in here, 13 degrees. So right now we have triangle 1. We'll call this one triangle 1, and this triangle 2. So for triangle 1, we have angle A, 42, that was given. We have angle B, 55. That's what I solved down here. And angle C, adding these together, subtracting from 180 gives me 83 degrees. All right, and then I have, of course, my side A, which is 52, my side B, which is 64, and my side C, which I have not yet found. So that's triangle 1. We'll finish that side C in a minute. All right, and then I have triangle 2. So let me just put it down here and run out of room. Triangle 2, I have angle A, that was the given angle, 42 degrees. I have angle B, and that was the other possibility for angle B, which was 125. And if A is 42 and B is 125, then angle C has to be 13 because I have to add up to 180. And then again, A was 52 and B was 64 and C, I don't know yet. Got to find that. So these are the sides in. So it's possible to have two triangles that contain these parts, 42 degree angle, 52 and a 64 side, 42 angle, 52. And so they're two totally different triangles that have those given three parts. All right, now, so I have two triangles I have to solve, and I've got everything I need except the last side, which is side C. So I'm just going to do one more little law of sines here to find C. So I'm going to say C is which I'm trying to find over the sine of angle C. Let me go ahead and fill angle because I don't have a lot of room here. So angle C is 83. And I'll just do A over the sine of A, so 52 over the sine of 42. All right, I'm going to cross multiply. C times the sine of 42 equals 52 times the sine of 83. So I'm going to have C 52 times the sine of 83, and then I'm going to divide by sine of 42. So due to room, let me just go ahead and type that in as it is. 52 sine of 83. Take this out. 52 sine of 83 divided by sine of 42. All right. And the answer is C is 77.1. Everything I'll keep to 2 significant digits to keep consistent. So we'll say 77. So side C is 77. So 77 centimeters, 77. All right, on the other triangle, I could do the same thing. I could say this is side C. I'm trying to find C over the sine of angle C, but angle C in this one, I'm going to use the same. I'm just going to fill in the right parts on this so I don't have to rewrite all this. And I just don't have the room. So sine of 13 degrees, angle C, equals A. These aren't going to change. I can still do A over the sine of A. So now when I cross multiply, everything's going to be the same, except this is going to be a 13-degree angle rather than a 83. So let me go to my calculator and I'll just change that one angle. So it's 52 sine of 13 divided by the sine of 42. And I get 17. And so this on this triangle C would be 17. All right, and that solves both. So that's a case where you are given two sides in an angle that's not the included angle, and there's two totally different triangles. You're looking at them right here that can contain those two sides in that angle, and they look like that. All right. Okay, example 3. Let me draw my triangle. Angle A, don't know that angle. Angle B, don't know that angle. C, 37.2 degrees. Side A, 105 feet. Side C, 215 feet. Side B, no idea yet. Okay, so let's start our process. This is, again, side, angle. The angle's not between the two sides, so this is going to be one of those ambiguous cases. We don't know if there's one triangle, two triangles, no triangles until we get into it. So, all right, so I'm going to start. I got to find all the missing parts, but I'm going to start with angle A because I've got side A and I've got the pair of angle and sides on C here. So C over sine of angle C equals A over sine of angle A. All right, C is 215. Angle C is 37.2 degrees. A is 105, side A. Sine angle angle A, I don't know, is what I'm trying to find. So I cross multiply, so I have 215 times the sine of angle A is equal to 105 times the sine of 37.2 degrees. And solve. So divide both sides by 215. And I get the sine of angle A equal to, all right, back to my calculator, 105 sine of 37.2 over 215. All right, 0.2953. All right, so now I'm inverse sine. So A is going to equal the inverse sine of 0.2953, and that will give us the angle 2953 in degrees. So angle A is going to be, go back and stick an inverse sine in front of that. The easiest way to do it. Inverse sine. All right, 17 degrees. Actually, they carried 3 significant digits, so I'll say 17.2 degrees. 17.2 degrees. All right, so this angle is 17. Let me put that in since it's one I found in a different color so we can tell what's given from what I found. All right, now I can find angle B because it's just a 180-degree rule. So 37.2 and 17.2 is 54.4. No, sorry, 58.4. All right, 58.4, and then I need 180 minus 58.4. Wait, no, I can't read my own writing. That's a 17, so I was right the first time. Let me back up. All right, so I need to make this look like a 7, so I know it's not an 11. All right, so that's 4, so it is 54.4. 54.4. All right, so 180 minus 54.4 is 125.6. So this angle, obviously this is not drawn accurately, but it doesn't matter. We just need kind of some for reference there. So I've got my angles done with that part. That leaves me, I didn't finish the part down here. So the angle A could be 17.2. The sine would also be 0.2953 positive in quadrant 2. So if the reference angle were 17.2, the angle in standard position would be 180 minus 17.2. So 180 minus 17.2 would be about 162.8. So that's also another option. So I've already done the 17.2 one. Let's say in this angle we're 162.8 instead of 17.2. So 162.8 and 37.2. So if you add those together, to find out what the other angle is, you will see quickly that we get 200 degrees in just these two. And this angle is 162.8. That's not possible because that's already over 180 degrees. So in that case, I would rule this one out because it doesn't work in this triangle. You can't have this angle be 162.8. So if that would work, then we would have the two triangles like we had in example 2, and we would have to go ahead and solve both. But when this angle is combined with the angle you're given is too big, you've already used over your 180 degrees, then you can't have a triangle. You can't have a third angle. So this is not possible. So we don't have to worry about that case. This is just one simple triangle. And so I know I have angle A was given. No, angle A I found actually. B was one I found. C was the one that was given. And we were given side A to be 105. We were given side B to be 215. And side C, I don't know yet. I got to find that. So let me just do the law of sines to find it. Side C. So C 215 over the sine of angle C, 37.2. B is what I'm looking for, equals B over the sine of angle B, sine of 125.6. Now, if I solve that, cross multiply 215 times the sine of 125.6 is equal to B times the sine of 37.2. And then I'm just going to divide both sides by the sine of 37.2. All right, and we end up with B equals, so I got to go back to my calculator, 215 215 sine of 37.2, and that is over 105, I believe it was. Let me look back and check. Hold on. 215 sine of 125 divided by the sine of divided by the sine of 37.2. Whoa. This should have been 125.6. 37.2 goes on the bottom. Sine of 37.2 on the bottom. 125.6 on top. Okay, so 289. 289. So B, or C rather, is 289. And there's all the parts solved. So yeah, Set up my loss signs. When I got to here, I had the two values. This one, I plug it in. I add the two angles and subtract from 180 to get the third. When I try this one plus it's already over 180 means there can't be a triangle with this side with this angle. And so I only have to solve for one triangle. And then I just did loss signs to find the missing side B, which was 289. All right, example 4 is asking you to go back to the first triangle, and I went ahead and looked back at example 1, and I drew the triangle and I labeled it. This is what we were given in problem 1. It says this time do the same problem, but instead of using law of sines, use law of cosines. All right, so let's remember what law of cosines is. It was, all right, it was, let me start with the first one. So a squared equals b squared plus c squared minus 2bc cosine angle A. And then I have the b squared equals a squared plus c squared minus 2ac cosine angle B. And c squared, so the other two sides, a and b, a squared plus b squared minus 2 times ab times the cosine of angle C. Notice the angle here always matches the side that you're solving for. So I'm looking at what I know. I know side A, I know angle A. So I'd have to do, if I'm trying to find one of the, like side C, I'd have to, I know angle A, I know side A, and I know side B. So I should be able to use the first one here, filling in everything I know, and I would be able to then solve for side C. So let's start with that. All right, so coming down here, I'm going to use the first one. So I'm going to write this down, but I'm going to fill in what I know. So instead of a squared, that's 4. 4 squared equals b squared, that's 12 squared, plus c squared is the one I don't know. This is what I'm trying to find. Minus 2 times b, 12, times c, I don't know what c is, times the cosine of angle A, and angle A is 35 degrees. Now, because I know everything except C, I could solve this. So let me clean it up a little bit. 4 squared, that's 16. 12 squared, that's 144. C, I don't know. This is going to be, this is going to be 24 times the cosine of 35. So let me go ahead and go to my calculator and figure out what that is. So cosine of 35, I'm going to multiply that by 24, so it was, 2 times 12, so 24. So that is 19.7. All right, so actually I'm just going to say 20 because I'm carrying two significant digits. So we'll leave it at 19.7 now, just for rounding purposes. I don't want to round off intermediate answers too much. So matter of fact, I might even go with 19.66. And then I'll round my final answer off to two significant digits. All right, so first thing I see is that, the C, don't lose the C there, the variable. So it's 2 times 12, 24, 24 times the cosine of 35 is 19.66 C. All right, so now I see that it's quadratic. So typically when it's quadratic, what do we want to do? We want everything on one side equal to 0. So I'm going to have my C squared. I'll go ahead and put them in descending order of powers there. So 19.66C, and then I'm going to subtract the 16 over, so I have 0 over here, 16 over, and so I get 128, and that will all equal 0 because we've moved everything to one side equal to 0. All right, so obviously with this kind of linear coefficient here, this is not going to be one that is factorable, so we're going to have to go to the quadratic formula. So let's do that. So I've got to have x equals, or c equals in this case, negative b. B is 19.66 plus or minus the square root of b squared. So that's the 19.66 squared. Doesn't matter if it's negative because it's going to be squared anyway. Minus 4 times 1 is a. I don't even need to put 1 there. Times c, 128. All over 2 times a. 2 times 1 is 2. Okay, so I have 19.66 plus or minus. All right, so let me go ahead and get the discriminant value here. 19.66 squared, 19.66 squared minus 4 times 128. All right, negative 125. Hold on. Yeah. So negative 125.5, I'll say. Negative 125.5. So negative 125.5 all over 2. Now, when I add 19.66, well, first of all, when I try to take the square root of negative 125.5, I'm going to get, there's no real answer, not the square root of a negative number. So there's no real answer to this. So there is no answer, which means there's no triangle possible. And that's exactly what happened when we go back to look at example 1 that we had already done. Remember, there was no triangle possible. So we just took the same problem and worked it using law of cosines rather than law of sines. All right, same thing with number 5. So we're going to work number 5 just like we did number 2. So let me draw the triangle. Now this is the one, if you remember, that had 2 triangles possible. So let's see how we realize those 2 triangles when we're doing law of cosines here. All right, so I'm going to call this A, B, C, and I'm going to have to flip back to look at what the parts that were given in example 2. All right, so we were given angle A, 42, side A, 52, and side B, 64. All right, so I have angle A, 42 degrees, side A, 4.0, and side B, nope, not 4, that's the last problem, 52. Side A was 52 centimeters and side B was 64 centimeters. Okay. So again, I think I'm going to use the same law of cosine. So let's go with A squared equals B squared plus C squared minus 2BC times the cosine of angle A. All right, filling in what we know. A is 52, that's side A. B, 64. 2 times B, 64, times C, we don't know, times a cosine of 42 degrees. All right, so I'm going to calculate some bigger numbers. So let me get 52 squared. This is 2,704. 64 squared is 4,096. This is minus 128 times the cosine of 42. So let me go up here, cosine of 42. And times 128. Whoops. So it's 95.12, we'll say. So minus 95.12C. So I multiplied the 128 and the cosine of 42 and got that. It says don't lose the C. All right, so let's get it cleaned up a little bit. Let's get everything on one side equal to 0. With the leading, let it lead with the quadratic term C squared, then the linear term minus 95.12C. And then let's subtract over the 2704. All right, and that's going to leave 0 on the other side. And then 4,096 minus 2704 is going to be plus 1,312. Okay, so again, not a factorable problem. Let's quadratic formula it. So x, or c, I should say, is equal to negative b plus or minus the square root of b squared minus 4 times a times c. Of course, I don't really have to have the 1 here. All right, over 2 times a, 2 times 1. Okay, so this is going to be 95.12 plus or minus. Now let me get that Bradicane, let me get that discriminant value. So 95.12 squared minus, remember, 4 times 1312, basically. So minus 4 times 1,312. All right, there it is, 3799.8. So this is 3799.8 all over 2. Now, this is a positive number this time, so it's not going to be a no triangle case. It's not going to be undefined, no real answer. So now I want to take the square root of this number and then add that to 95.12. So 95.12 plus the square root of that over 2. Let me do that first. All right, so I got this value. I want to just let me just take the square root of that whole thing. Put a square root symbol in front of it. No, it's not gonna do it. Okay. So let me go back to what I want square root of. I want square root of 3799.8. 3799.8 is what's under the radical. Let me get rid of all this mess. And then 95.12. I'll do the plus one first. And all that is over 2. Okay, so let me double check it. 95.12 plus 37, square root of 3799.8 divided by 2. Answer 78.4. So 78. Keep it the same significant digits. So C could be 78, or C could be 9. I mean, to go back and just change the plus to a minus to get the other answer. So good thing I've already typed it in, so it makes it easy. All right, so 17 would be the other answer. 17 would be the other answer. All right, so C, so that's where your 2 triangles come in, and you can get C could be 78 or 17. So now that I've got all 3 sides, I've got this angle, then I could go ahead and do law of sines, just basic law of sines, and find angle C. And if I know angle C and angle A, I've got angle B. So let me go ahead and do that. Let me do, let's say it's 78 first. So 78 over the sine of angle C would equal, let's say 52 over the sine of 42. And then I can do 17 over the sine of C equals 52 over the sine of 42. So 52 sine C equals 78 sine of 42. Cross multiply. Divide both sides by 52. Now on this one, it's going to be It's going to be a 17 times the sine of C. I'm sorry, 52 times sine of C equals 17 times the sine of 42. So it's going to end up being C equals 17 sine 42 over 52. So it's going to be just like this one, except the instead of 78, it's going to be a 17 there. All right, so let me go type that in. So 78 sine of 42. (78 sine of 42) over 2. All right, so I get 1. 78 sine of 42 over 52. All right, 1. Okay, as I was looking at the calculator, I was coming up with undefined on this value, and so I knew something because we did this problem in 2, and this is the one that has the 2 triangles, and so these are the same values. Now this one's a little because probably just due to rounding. I think we got 77 when we did it number 2, but I realized there's got to be something wrong somewhere, so I went back to look at, and I see what I did wrong. It was this subtraction right here, 4,096 minus 22,704 is not 1,312. It is actually 1,392. So that screwed everything up. So let me just fix that little, that's going to make this 1,392. So let me just fix that in my calculator, and tell you what, I'm just going to type the whole thing in as it is instead of piecemealing it here. I'm just going to put the whole thing in. So let me just take this all out. All right, so just that one little subtraction error just threw everything off enough that I knew something was wrong. Because we've already worked the problem, so we should get the same answers, minus give or take a little bit for rounding. But so let's see here. So let me go back to the calculator. I bet I've deleted that. No, it's still up here. Okay, clear that. So I have 95.12, and that is minus a negative. It's going to be plus. Okay, plus or minus. So I'm going to start with a plus. 95.12 squared minus 4 times 1392 divided by 2. Okay, so 77 would be one solution. Or now I got to do the minus. 95.12 minus all that over 2. So a good thing it's already in the calculator. I just go back and I would just change this to a minus, and it's 18. So 77 or 18 would be my 2 potential sides. So it was off just a little bit. I had 78 and ended up making it undefined when I did the law signs define angle C, so I knew something was wrong. All right, so this is now 77. Could be 77 or it could be 18. So when I set up my C, so it should be 77 instead of 78. 77 over the, fix that. All right, so 77 over the sine of angle C equals 52 over the sine of 42. And this would be the other 18 over sine of C equals 52 over sine of 42. When I cross multiply, 52 times the sine of C equals 77 sine of 42. And then divide by 52, so I need to type this in to get angle C. Well, that'll give me the sine of angle C. And then I'll inverse sine to get angle C. And then I need to do the same thing over here. I'll get sine of C equals whatever, and it's angle C. So and this is going to be 18. All right, so let me do the one on the left first. So 77 sine of 42 over 52. All right, and then that's 0.99. So if I want to kind of insert that, 0.9908, 0.9908, and then I would inverse sine 82 degrees. All right, so angle C could be 82 degrees, or 8. I'm going to change the 77 in the calculation to an 18. That's the only thing that really changes. So the 18, 77, let's just change it to an 18. I won't even worry about the intermediate step. And so the other angle is 13 degrees. And angle C would be 13 degrees. So C could be 82 or 13. So remember, if you go back to problem example 2, we did the very same problem by using law of sines. It was the ambiguous case. It ended up being two triangles. We had side C could be 77 with angle being 80, angle C being 82, or the other case, side C could be 18 with angle C being 13, and those were your two triangles. I'm not going to list all the parts because I did that back in example 2, but that is how you can use law of sines to do it. All right, the last one of those, we'll get angle example 3. So let me go back and pick up the parts. I don't remember what they were for example 3. I do remember that this one only had one triangle possible, so that'll make things a little easier. Back to number 3, we're doing example 3 by law. So I have angle C, jot those down so I don't forget them, 37.2, A 105, and C 215. All right, so let me go back and let's label this. All right, so C, 37.2. That's the only angle I know. I know side A is 105, and I know side C is 215. All right, so to do this one by law of sines, I'm going to probably need the one that says C squared equals A squared plus B squared minus 2AB cosine C. Now, how did I know to use that one? Well, because I've got angle C and side C, so I need the one that's got those two parts. All right, and so let's fill in what we know. So C is 215. A is 105. Now, as you're doing these, you can kind of think back to which way is easier, doing the law of sines, even though it's the ambiguous case, or doing law of cosines. Personally, I would rather do law of sines any day. It's just much less tedious, but both ways work, so just a personal preference. C is 37.2 degrees. Even on the case with two triangles, I mean, I still would prefer law of sines. All right, so 215 squared. 46,225. 105 squared. 11,025. Okay, this is going to be 210 times the cosine of 37.2. And then don't forget the variable b. All right, cosine of 37.2. That was multiplied by 2 times 105, so 210. It's at 167.27. B, so don't forget that variable right there. All right, so let's clean it up just like the other two that we've done. Let's clean it up a little bit. Lead with the quadratic term, then the linear term, and then the constant. So I'm going to subtract this over. All right, so since I made a subtraction error in that last problem, I'm going to use my calculator this time, not trust myself. 46,225 negative, so 11,025. So negative, let me make sure I got it right. Negative 46,225 plus 11,025. All right, so negative 35,200 is the result. And that is all equal to 0 because we've got everything over here. So 0. All right, again, quadratic formula, it's not factorable. So b equals negative, b kind of means two different things here, but negative b, so minus a negative 167.2 plus or minus the square root of b squared minus 4 times a times c all over 2 times A. All right, so this is going to be side B. So let me jot that down so I don't ever have to go back and forth so many times. So 167.2 plus or minus. Okay, calculator. So all right, I'm gonna type it all in one shot here. So 167.2, that can be positive because it was minus a negative. Square root of 167.2 squared. So even though that's actually negative, it's not going to matter because it's going to be squared. Minus 4 times 1, I'm not going to put, times negative 35,200 all over 2. Okay, so I get 288.9995. Let's say 289. 289. It's one option. So B could be 289, or B could be the subtraction. So we'll do 167.2 minus all that. So I'm just going to go to my calculator, change the addition to the subtraction to get the other case, and negative 121.8. Okay, wait a minute. That, all right, so is it possible, so B could be 289. Would it make sense that B could be a negative, the side could be a negative length? No, it can't have a negative length. So that's how we end up with one triangle here. So 289 is the one that we go with. And then I would need to go ahead and solve for angles, either A or B. It doesn't matter which one. Once you get one, then use the 180-degree rule. So let's say I find angle A. So I know 105 over the sine of angle A equals C over the sine of angle C, because I know both of those. All right, that will allow me to find angle A. So 215 times the sine of angle A is equal to 105 times the sine of 37.2. Divide by 215. And sine of angle A would be 105 sine of 37.2. And that's over 215. All right, so 0.2953. And then I need to inverse sine to undo sine. So A is going to be the inverse sine of 0.2953. And I will just go type an inverse, put an inverse sign in front of that value. Inverse sine. All right. 17. So angle A, I should carry 3 significant digits, I guess. So we'll say 17.2. Now, so A would be 17.2. I kind of already know that there's not two triangles because we already saw that here. But, you know, I know that not only does the sine of 17.2 equal 0.2953, but so does that same angle in quadrant 2, which would be 180 minus 17.2. And that is 162.8. But this couldn't be 162.8 because that would add with 37.2 to be over your 180 degrees. So I don't have to worry about this one. It's out. I've got A, and now I can just use the 180-degree rule. So 17.2 plus 37.2 is 54.4. If I subtract that from 180, this angle would have to be 125.6. So you obviously can't go by how it's drawn, and I have solved the triangle. I found all the missing parts using. So we solved those 3 examples we did by law of sines. And then we redid them using law of cosines, showing you can do both cases. Now, most people prefer law of sines. It's a little simpler formula. And even with the ambiguous case and the case that there could be two triangles, I still think that's the easier route, but both of them are available. All right. Okay, this is an application problem. This is our last example. All right, in this problem, we have let's just kind of read through and figure out what's going on here first. So a plane is flying with an airspeed of 170 miles per hour and a heading, so remember we talked about headings in one of the previous sections, of 42.3 degrees. So it's true course. So remember the heading, so let me kind of just draw that out. So you've got, here's due north. And so a heading means it's 42.3 degrees clockwise from north. So 42, let's just say it's somewhere right in here. So this would be 42.3 degrees. So this is the actual intended path of the plane. It's the way the plane is heading in that direction. Its true course, however, is at 52.5 degrees. So it's actually flying at its actual displacement, including the displacement, is going to be this whole angle right here, which would be 52.5 degrees. All right, so this is the true course. So what's happening is it tells you that there's a 55 mile per hour wind acting. So the wind is blowing through here and causing the plane to displace. And so I've got my triangle here formed by the vectors, one representing the intended path of the plane, the heading of the plane, the wind vector acting on that, and then the actual true course where the plane has been displaced by the wind. Now on this triangle, one thing I see right here is that if this angle is 52.5 and this angle is 42.3, I could fill in this little angle in the triangle here, which will probably be helpful. So 52.5 and 42.3, I subtract those. 52.5 minus 42.3 is 10.2 degrees. So this little angle right in here is 10.2 degrees. All right, now let me come out here and let's draw. So we've got kind of the drawing laid out. I can label my airspeeds on my vectors. That would represent the magnitude of the vector, 170, 55 for the wind. And then the other one, the actual true course here, it would be the one I'm trying to find. It wants to know what the actual ground speed of the plane is. Okay, so the possibilities for it. So let me draw the triangle a little bigger over here. So we have this vector being the heading of the plane, direction it's intending to head. This is the wind speed, and this is the true course, which is the one I'm trying to find. So I'm going to call it, just so I can name it, ABC. So this angle in here we know is 10.2 degrees. So the airspeed of the plane is 170 miles per hour. This is the speed of the wind acting on that. It's causing this displacement. And then this is the true course of the plane. So after the wind has acted on it, it has moved the plane, so it's no longer flying on its intended path, but this is its true path. And so we want to know the speed along that. So that's going to be side C that we're trying to find. So it comes down to this is a side angle case, so we can use law of sines. It could, but we have to know that there could be two triangles, there could be one triangle, there could be none. So we're going to have to go through and take that in consideration. So there could be two possible answers for C. So we'll see what happens with this one. So let's start at A over sine of A. So I've got both those. So 55 over the sine of angle A, which is 10.2 degrees, equals. I can't do C over the sine of C because I don't know either one of those. So I'm going to have to go B over the sine of B, and then once I get B, I can find angle C, and then if I get angle C, I can find side C. So I will do B, which is 170, over the sine of angle B, which is what I'm trying to find. All right, so let me set that up. So 55 times the sine of angle B is equal to 170 times the sine of 10.2 degrees. And then we divide both sides by 55. And we have sine of angle B equals, okay, go on to my calculator. 170 sine of 10.2. Divided by the sine of, oh no, not sine, but just divided by 55. So scratch the sine, just 55. All right, 0.5474. All right, so angle B is going to be the inverse sine of 0.5474, which is, I'm going to go back and just add an inverse sign in front of that. (33 degrees). All right, so angle B could be 33 degrees. Now, so 33 degrees here. We know that sine also has a positive point. Sine of what angle has is positive 0.5474 in quadrant 2. So the reference angle being 33 degrees. The angle would be 150 minus 33, so that's going to be, 147. All right, so angle B could be 33. We know that would work. Will 147 work? And the answer is yes. So it could be 33, or I can redraw it, and this time if I swing this angle through, remember how that works, I could redraw it like this, in which case angle B would be 147. This is still 10.2. And then I'd have to find the angle C under each condition. So 10.2 and 33 is 43.2 from 180. It's going to leave this being 136.8. And in this case, if this is 10.2 and this is 147, it's going to be 157.2 from 180. And so this third angle would be, it's an 0, 22.8 degrees. All right, so now I just got to find angle C under both cases. So unfortunately, we have two different options here. So we're going to have two different answers, two different possibilities for the ground speed of C. All right, so on this triangle, I'm going to do C over the sine of C, angle C, which is 136.8, equals, I'll just go with A over sine of A. So that would be 55 over the sine of 10.2. So when I cross multiply, C sine of 10.2 equals 55 sine of 136.8. All right, and then I have to divide by the sine of 10.2, and then I'll go to my calculator and get that. All right, 55. Scratch that. So 55 sine of 136.8, I believe it was. Yes, divided by sine of 10.2. All right, 212.6. Let's just say 213. Keeping consistent with. So this one would be, do it in red so we can. (213 miles per hour). Okay, and then down here, rather than I don't have a lot of room, so let me just redo it. So this is A, B, C, C, 22.8. So I would just need to change side C side C, that's what I'm trying to find, over the sine of 22.8 this time equals 55 over the sine of 10.2, so everything is the same. So all I need to do is go into my problem and change the 136.8 to a 22.8. I get 120.4, we'll say 120. All right, and so there's two possible answers for that. So because it was the case, the ambiguous case, we didn't know until we got in there that there are two different triangles that can have those parts. So C, representing the ground speed of the plane, could be 213 miles per hour. It could be 120 miles per hour. So again, as I drew the heading of the plane, 42.3, the true course, the little angle between those is 10.2. That gave me, if I labeled everything else I knew, I had the case of side-side angle. I was trying to find the magnitude of C, given the magnitude of this vector and this vector. And so it just came down to being a ambiguous case of side-side angle. I was able to use the law signs. I did have the two cases though, which makes for more work, but that's, still I would still prefer doing law signs over law cosines just because the formula is a little more simplified.